Alright guys, I'm going to show you guys how to use direct variation to solve problems. Alright, we're going to begin with the definition for direct variation. Direct variation is a relationship that can be written as y equals kx. So we've done this a little bit before. So in this relationship, k is what we call our constant. We've also called it our slope. Now, how do we find k? Oh, great question. We find k by using the ratio y over x. So k is equivalent to y over x, where x is our input and y is our output. So I'm going to show you guys a little bit how to do this, and then we'll practice. How do we check for direct variation? Well, we want to check each ratio in our data table to see that the proportions are all equal. Each of the proportions in the data table, the y to the x, needs to be equal. If they're not, then we do not have direct variation. If they are, then we do have direct variation, and then we need to write an equation to represent the data in that table, and I'll show you exactly how to do that. But our equation will be in the form of y equals kx. Our k will be the ratio that is constant throughout that data table. So we'll take that ratio and we'll insert it into our equation. And then I'll show you how to make predictions based on the equation. Again, if it's not direct variation, we will simply just write not direct variation. Let's practice. So first thing we need to do is we need to set up each proportion in the form of y over x. So this is my data table. You can see here that the current is my y value and the resistance is my x. So what I'm going to do is I'm going to set up each proportion. 4 over 3, 2.4 over 5, 2 over 6, and 1.5 over 8. Now these are simple division problems. I suggest using a calculator as opposed to having to go ahead and divide them out. So we would divide what is 4 divided by 3. Is that 1 1/3? 2.4 divided by 5. Ooh, well I know it's not 1/3. 2 over 6. No, 2 over 6 is 1/3, right? So as we go through and we solve for each of these, we're going to realize, hey, these are not equal. And if they're not equal, that means we do not have direct variation. So we would write not direct variation. So you saw what I did is I set up each of my proportions, y over x, for each one, and then I solved each of these proportions. And now I'm checking to see, are the values of each of those proportions the same? And if they're the same, then I can move on. If they're not, I stop and I'm going to write not direct variation. Let's do 2 more. So we have x the weight and y the dosage. So I'm going to go ahead and set up my proportions. So 160 over 8, 300 over 15, 560 over 28, and 940 over 47. Alright, and now I want to solve each of these proportions to see, is this direct variation? So 160 over 80 is 20, 315 is 20, this is 20, and this is 20. So you can see all of my proportions, all of my ratios are identical. That means I have direct variation. So yes, this is, yes, direct variation. Now I need to write an equation to show exactly what it looks like in an equation. Remember, we use this form, y equals kx. Well, what have we identified? Remember, we used y over x, and y over x represents my what? My k, my slope. So this is k. So 20 is my k. So what I'm going to do is I'm going to input this 20 for k into my equation, and I'm going to rewrite the equation. So y equals 20x. So the equation that represents the data in this table is y equals 20x. Fantastic. Let's do another one. So here I have y at bats and x games. So I'm going to set up my proportions. 62 over 20. 93 over 30, 155 over 50, and 496 over 160. Again, I suggest using a calculator due to these division problems. I've already gone and done them. I know that each one of these proportions is equivalent to 3.1. And because they're all exactly the same, that means we have direct variation. So yes, direct variation. Now I have to write my equation that represents the data in the table. Remember, we're using the format y equals kx to write our data for our equation. 3.1 represents which of these values, the y, the k, or the x. Again, it represents the k. So I'm going to insert 3.1, replace my k with that 3.1, and it's going to be rewritten as y equals 3.1x. Alright, I'm going to use this equation here to show you how to make predictions for the future. So I want to know, let's say they asked you on this problem, after you found your equation, they asked you, what dosage would we give to somebody that had a weight of, let's say, 80? Right? So that would be our x value, right? 80 represents our x. Okay, how would we do that? So what I would do is I'm going to take my equation, y equals 20x, and what it's really asking us is, if the weight is x, then what is the y? X being our input, so what is the output? Right? What is the output if x is 80? Well, we know the equation, y equals 20x. So what I need to do is I need to put this 80 in for which of these values? Does 80 represent my y, or does 80 represent my x? Exactly my x. So y equals 20 times 80. And when we solve that out, 8 times 20, 80, 20, right? 0, 0, 0, 0, 0, 16, 1,600. If x is 80, then y would be 1,600. Now you can do the exact same thing if they give you your y dosage. They say, hey, if the dosage is 2,400, what is the weight? Well, we would do the same thing. We would rewrite the equation, y equals 20x, but instead of inputting the x value, we input the y value and then solve for x the other way around. All right, I hope this helped. Let me know if you have any questions. Good luck.